integer quantities of radians are not rational multiples of 180 degrees of a half turn. So they're not easy to compute with. So 1 radian, just to remind you, 1 radian, well, 1 radian, so let's see, pi radians is 180 degrees. So 1 radian is 180 degrees divided by pi. So that turns out to be about 57 degrees. 2 radians, that is 2 times 180 divided by pi. Here's 3 radians. So 3 radians, that's less than 3.14 radians, which is pi, which is 180 degrees, this is approximately pi. So this number here must come before a half a turn. Here are 4 radians, here are 5 radians, 6 radians, that must be before a full turn, because 6 is less than 3.14 times 2. So 6 radians must be less than a full turn. And here's 7 radians, here's 8 radians, and so on. This goes on for a while. Now notice that since all of these, since an integer number of radians is not a rational number of degrees, these marks here, they'll never repeat. So we'll never visit if we start marking off integer amount of radians on the circle, on the unit circle, we'll never visit the same place again. So these marks will never hit in the exact same spot. So that hints to the difficulties, to the numerical difficulties of computing with radians. For example, if you want to determine in which quadrant a given amount of radians lies, this is not so easy to do, because think about it. If I ask you 8 radians, in which quadrant it lies, you need to first convert it to degrees, and then look between what multiple of 90 degrees that amount of degrees lies, right? So you see that 8 radians, that is about 458 degrees, and 458 degrees happens to be bigger than 450 degrees. That's 5 times 90 degrees, and it's less than 6 times 90 degrees. So for you to tell me in which quadrant does 458 degrees lie, you need to fit 458 degrees between multiples of 90 degrees. Now that's easy to do if you know the numerical value of given amount of degrees, but if I give you 8 radians and ask you how many degrees is that, what you need to do is you need to take 8 radians, okay, and that was 8, so that is 8 divided by pi times 180 degrees, right? And now to actually compute that, you need to know pi. So if you want to compute, to that, of course you could use a calculator, but your calculator is very powerful. It does a lot of computations. So if you want to compute this number without a calculator, you need to know the number pi with a great precision. So need to know pi, it's 3.1415 and so on, right? So you need to know many digits after the decimal point in the numerical approximation for pi. So when trying, say, to figure out if I give you a given number of radians, in which quadrant that the corresponding angle lies, you are going to run into issues of numerical computation. To anybody who disagrees with that, I propose the following problem. Take 2017 radians and figure out in which quadrant do 2017 radians lie without using a calculator, to anybody who thinks that this is an easy problem. Yes, why 2017? Because I'm shooting this video in the year of 2017. So once again, dealing with radians is naturally uncomfortable due to the numerical errors introduced by the number pi not being rational, and by the fact that every time you compute with the number pi, you need to introduce numerical approximations for the number pi.